Hi everyone, good morning. It's actually morning for me right now as I'm recording this class, and I have of course no idea what time of day you're watching this video, but I hope you're all doing really well. So this class is about differences analysis, and I'm going to try to make it as concise as possible. Differences analysis are the second type of analysis we cover in Marketing 470. And before I dive into the specific tests you can run in SPSS to find or uncover differences, I want to go over why difference tests even matter. So why are they important? So difference tests are mainly used for market segmentation. I'm sure you've all heard of market segmentation before. It's actually one of the most common and most useful marketing strategies. And it's entirely based on differences between consumers in terms of their preferences, their lifestyle, personality, their needs, and so on. So really, let's say, for example, the skincare market, cosmetics market, looks at differences in skin tone to manufacture or create different products that meet each consumer's needs. Or let's say, for example, different types of cars to match different personalities, different lifestyles, and so on. Now, in order to really rely on differences for market segmentation, these differences must be statistically significant. So there's nothing you can do with assumed differences. It's not because you think there is a difference between two subgroups in your sample, let's say, for example, males and females, that there actually truly are significant differences between these people. So let's say, for example, gender. Gender is actually one of the most overused and most abused market segmentation variable. There's actually many examples of gender being used in almost a ridiculous way. So usually this comes with a hefty price markup, usually for the female products. What you see in this picture is deodorant for men versus women, and you see a pretty big price difference, even though the ingredients, except for maybe the type of perfume that's used, is pretty much the same. So I found this BuzzFeed article with tons of pointlessly gendered products. It's pretty interesting to see, so let me show you. Girl Yenga, I have no idea why. The Men's Mirror, I think it's totally ridiculous as well. What else do we have? Oh yeah, a lint roller that's specifically for men. Pens for her, of course, pink and purple. So the gender stereotyping is pretty strong here. So gift cards for guys versus girls, man-sized Kleenex for the man flu. Anyway, the list goes on and on, so feel free to take a look. A second criteria that has to be met is that differences must be stable. So, of course, you don't want to invest in very quickly fading or very fleeting fads or fashion trends that are quickly disappearing, because that's not a very stable strategy moving forward. If you want to base your marketing strategy on differences, ideally these differences will persist in the long term, will be trends that stick around for a while, will be more stable. And then lastly, differences must be profitable. So you may wonder, is it really financially worth it to build your whole marketing strategy, so your segmentation strategy, on different segments if these differences may not be profitable, or if these specific subgroups may not be profitable? Think of, for example, left-handed versus right-handed people. Certain products are made for left-handed people specifically, but certain products are not. So that's simply because the group of left-handed people is just in such a minority that it may not be financially worth it for companies to actually develop products specifically for that group. Or as you can see right here, this is Daya. This is a dairy-free pizza, dairy-free, gluten-free, meat-free, and so on. It's a vegan pizza brand. And if you look at the ingredient list, it's pretty long. There's so much in there, but surprisingly, there's a lot of allergens that are not in there. So no dairy, no gluten, no soy, no eggs, peanuts, and tree nuts, fish, or shellfish. So none of that is in there. Interestingly, if you go look at what is really still in there, tapioca, for example, what if people have a tapioca allergy? Well, so the group of the population that actually is allergic to tapioca is such a small minority that it may not be worth it to develop a separate product line that is also tapioca free, or free of tomato, or free of yeast, and so on. So sometimes at a certain point, you're creating smaller and smaller circles and groups of people, smaller and smaller segments that may not always be worth basing your marketing strategy on. Now, sometimes that's also a total shame, because in case of very rare but very serious diseases that only a very small minority of the population may have, it's still very important that medication is getting developed. R&D is actually being done on therapy for those diseases. Now, unfortunately, big pharmaceutical companies spend much more on marketing and on communications than actually on research and development. I have this graph right here to show you the differences that really many of the main pharmaceutical companies spend on marketing versus R&D. So this is very, very striking and very shocking also, realizing that a lot of treatment development, medication development should come from that strong R&D, while actually most of it is spent on lobbying, sales, and marketing. So when you wonder, are differences really worth pursuing? Sometimes it's a matter of resource allocation rather than a shortage of resources. Now, when we look at differences, of course, it's important that they are statistically significant. So what was that again? I'm sure you remember from MIS or statistics classes you've taken that there is such a thing called the null hypothesis, and also such a thing as the alternative hypothesis. So the null hypothesis, just to refresh your memory, always states that there is no effect or no difference, or no association, and so on. So basically, the null hypothesis states that there is nothing. The alternative hypothesis states the opposite. It states that there is an effect or there is a difference. Now, if you don't know which one is true, this is the number that will decide on that. So your p-value, which is usually shown as sig or prob in SPSS, is a number that always ranges from 0 to 1. If this p-value is smaller than 0.05, that means we have too little support for H null, so insufficient support for the null hypothesis. Therefore, we fail to accept the null, so alternatively we go for H1, and we can conclude that there probably is a significant difference. Please note the word probably, because you never know for sure. It's impossible to prove that something is not there, so you will always be using words such as fail to accept, fail to reject, and probably having a significant difference. However, if your p-value is larger than 0.05 as the cutoff point, then you could say that there is sufficient support for H null. So in that case, there probably is no significant difference indeed. So you basically confirm what the null hypothesis says, there is no significant difference. So this slide is incredibly important to fully understand, because we use these cutoff points of 0.05 as a determining factor for whether we found significant or insignificant results. So this 0.05, of course, corresponds to 95% confidence in our results, which ties back to the class on sample error. That means we allow for some margin of error. However, this p-value that we use as the cutoff point, or the way to determine whether our results are significant or not, is recently been contested more and more. It's actually surrounded by a lot of controversy. So I have a quick scenario for you, and I want you to think about what you would do in this case. So keep that cutoff point of 0.05 in mind. So imagine two new potential treatments for the coronavirus. They have been developed and are being tested on humans. Treatment A was tested on 100 people, and 40 of those 100 got better. Treatment B was also tested on 100 people, but only 35 of them got better. So let's say the p-value indicating the difference in effectiveness between treatment A versus treatment B was p equals 0.09. So that is larger than 0.05. What would you conclude based on that p being 0.09? Is there a significant difference between treatment A and treatment B? Now think for yourself, you can pause the video. Is there a significant difference between treatment A and treatment B in effectiveness based on that p-value? No, there is not, because the p-value is larger than 0.05. Based on that criteria, we would say there is no significant difference between treatment A and treatment B. However, if I were to ask you the question, which treatment A or B would you take if you had the coronavirus, which one would you take, A or B? Right? Most people would pick A, because at least that cured 40 of them versus 35. So it's really controversial how we rely on this binary cutoff point, P being 0.05 as the cutoff point, higher being non-significant, lower being significant. Whereas when we ask what it applies to us, we would be more inclined to go for one or the other, even though we know that statistically there is no significant difference. So this is a really interesting thing to keep in the back of your mind as we are analyzing our results. So even though your significance value, your p-value might tell you one thing, it's still important to not treat your data in a completely binary way, as in yes or no. So, of course, in the class about descriptive analysis, there is no such thing as significance because we're merely describing our sample values. However, in all of the other types of analysis that we cover in Marketing 470, differences analysis, associative analysis, predictive analysis, we use that H0 versus H1 description that I had on the previous slide as a way to determine whether we found a significant difference, significant association, or a significant effect. So whenever we find a p-value or a significance value that is smaller than 0.05, we can say that there is probably a difference or an association or an effect. So here's the 3 different tests that we use for differences. So the first one, paired samples t-test, is one test you use when you have 2 different means, so 2 different averages, coming from the same group, but coming from 2 separate questions answered by that same group. So let's start with that first one, the paired samples t-test. With a paired samples t-test, you have 1 group and 2 questions. Of course, they must be having the same measurement scale. So for example, let's say you have 2 questions, how much do you like chocolate and how much do you like candy? If you compare the average on question 1 versus the average on question 2, you would be doing a paired samples t-test. So a way to visualize this is really you have 1 group of people, let's say your sample in your database, and you have 2 separate questions, both measured in the same 1 to 7 point scale or 1 to 5 point scale. How much do you like chocolate? How much do you like candy? And the average liking of chocolate is 2.45. The average liking of candy is 3.12. So what you're going to do is compare these 2 means and see if they are different from one another. In other words, you want to know if your sample overall has a higher agreement with I like chocolate than with I like candy, or the other way around. So basically, if there's any differences in liking chocolate versus liking candy among your sample. So let's do this in SPSS right away. I do have a video where I explain extensively how to use SPSS for this type of test, but I'm quickly going to go over it in screenshots in this class as well. So do people answer differently to, for example, I am worried about global warming and gasoline emissions contribute to global warming? So we have 2 different statements, 2 different Likert scale statements, and we asked respondents to indicate to what extent they agree versus disagree with each of these 2 statements. So we want to see if there's any differences in agreement with statement 1, statement A, or statement 2, statement B. So we click Analyze, Compare Means, and then Paired Sample t-tests. And then you click in the 2 metric scaled questions you want to compare, namely these 2. So this is what it looks like with a screenshot in SPSS. You click Analyze, Compare Means, and then you go to Paired Samples t-test. And this window will open up as soon as you click Paired Samples t-test. So on the left side, as always, you have your whole menu option. You find your 2 variables you want to analyze. Keep in mind they should both be metric scaled, right? They should both be interval or ratio scaled. This is because you're comparing means. You cannot compare the means of nominal or ordinal data. Keep that in mind always. So interval or ratio scaled data goes in here, and then you click OK. And this is what your output will tell you. So your output first shows you paired sample statistics. So it gives you an overview of your 2 variables, the pair that you're comparing. I am worried about global warming. The average here is 5.82, the average agreement with I am worried about global warming. The average agreement with gasoline emissions contribute to global warming is 6.1. So our sample size is 1,000, not 2,000. So you see 1,000 right here and 1,000 right here. That's because we have 1 sample of 1,000 people, but 1,000 people answered this question and the same 1,000 people answered this question. We're just comparing the means of the same 1,000 people on question A versus question B. Now, based on our own judgment, if we see these 2 numbers, we would say that the agreement is higher with the statement gasoline emissions contribute to global warming. However, we must look at the p-value, at the statistical significance value, to truly find out if there is a difference that is called statistically significant. So therefore, we look at the second table, paired samples tests, and we see the 2 pairs right here, the single pair, so the 2 questions. And here is our p-value, or significance two-tailed, 0.000. Now, again, you can think for yourself, feel free to pause the video, but 0.000 is smaller than 0.05, so that means that we did find a significant difference between the agreement with statement A versus statement B. Now, how do you report it? So you could say that we found that the average agreement with the statement gasoline emissions contribute to global warming, average equals, so mean equals 6.10, is higher than the average agreement with I am worried about global warming. Mean equals 5.85. And here you have your degrees of freedom, your t-score, and here most important to report is your p-value, which is smaller than 0.001. It's actually 0.000. So you could include a figure or a graph if you want to, but overall you could say that this agreement with both statements is high, because on a 7-point scale, both of these are very high. The second test you can run in SPSS to find differences is when you are looking at two means coming from two different subgroups in your sample on the same question. So one question, but two subgroups. Let's say you want to compare males and females instead of comparing two questions. In that case, you do an independent samples t-test. So again, with an example, let's say you want to know how two different subgroups differ on one question. So males versus females in your sample both answer the question, how much do you like chocolate, on a scale from 1 to 7. So you would compare the mean of men versus women on this question. A way to visualize this would be having two separate groups, group 1 and group 2, and they both answer question A, and you compare the mean of this first group on question A and the mean of the second group also on question A to see if there's a difference between these two means. So this is exactly what an independent samples t-test does. Two subgroups, one question. Let's do this with an example in SPSS. Is there a difference between males versus females in their agreement? I consider myself a craft beer enthusiast. So you ask one question. I consider myself a craft beer enthusiast, and people indicate to what extent they disagree versus agree. So ranging from strongly disagree to strongly agree. They think about this statement. And we ask this both of males and females, so we want to compare the means of males versus females. So in this case, we do use gender as a segmentation variable. Again, I have a video specifically on how to do this in SPSS as well right here. So with screenshots, what you would do is click Analyze, Compare Means, and then Independent Sample t-test. You click in the interval or ratio scaled variable you want to compare the means of, and you select your grouping variable. Your grouping variable in this case would be gender, because you want to compare males and females. You have two subgroups. So you click Analyze, Compare Means, and then Independent Samples t-test. As soon as you click Independent Sample t-test, this window opens up, and you look on the left side right here to find your metric scaled variable. In this case, lifestyle, I consider myself a craft beer enthusiast. And you click your grouping variable in, which in this case is gender. You define your group. So if you click Define Groups, you have to enter 1 and 2, which are the codes representing males versus females. You click Continue and hit OK. So this is what your output will show. You have the statement, I consider myself a craft beer enthusiast, and you see the average for males being 3.40, and the average, the mean for females being 2.84. We had 77 males in our sample and 58 females. You see sample size here for males versus females. Now, are these two means different from one another or not? That's the question. So to find out, you look right here in your significance two-tailed in the next table of your output. The p-value is 0.015. This is smaller than 0.05, so yes, there is a significant difference between males and females in terms of how much they consider themselves craft beer enthusiasts. Males have a higher average than females. There's one more thing you do have to look at when you run an independent sample t-test, and that is that Levene's test for equality of variance is right here. Let me explain on the next slide what that means. So the Levene's test for equality of variance is pretty much a test within a test. It's a way to look at the variance differences between your two subgroups. So since you're running an analysis with two subgroups, males versus females, these subgroups can have different variances, right? Like, for example, a different standard deviation on that question between males and females. So this is a test within the independent samples t-test. Think of like a little kangaroo test within the independent samples t-test, which looks at the equality of variances. So if your variances are equal, you would actually see a significance value here of 0.906, because if that significance value right here is larger than 0.05, that means your variances can be assumed to be equal. However, if your significance value here is lower than 0.05, then you can assume that the differences are not equal, so you would have to look at the second row. Now, usually it doesn't matter whether you look at the first row or the second row, because in most cases, the output would be leading to the same interpretation, but sometimes there are differences, so you need to know whether you look at the first row or the second row. So how do you report that data? You could say that we found that on average, men consider themselves more craft beer enthusiasts because their mean was 3.40 than women with their mean of 2.84. You have your degrees of freedom again, your t-score, and here your p-value being 0.015. Now, what does this really mean in terms of marketing implications? What implications does this have for marketing? If men consider themselves more craft beer enthusiasts than women, then what would you do with gender as a segmentation variable here? So what you could do is target mostly men with craft beer ads and Instagram posts, or you could show ads more in places where men go because men are already more craft beer enthusiasts. Or the opposite, you could make craft beer more attractive to females or make it more gender neutral to bring in females to make them more enthusiastic about craft beer as well. So this is how these results tie into actual decision making and implications for marketing. The last test in SPSS for differences is the analysis of variance, also called ANOVA. Analysis of variances. So that is when you compare more than two means, so multiple means coming from more than two subgroups on the same question. So instead of having two groups compared on question A, which was what the independent samples t-test did, now we have several different groups and they all answer question A, and we want to see if their means are different. For example, freshmen, sophomores, juniors, and seniors, and you ask them the question, how much do you study? Then the average amount of studying might be different for these subgroups in your sample. So in SPSS, this is how you do this. Does the average agreement with the statement, I am worried about global warming, differ across age groups? So let's say you have a couple different age groups, 4 or 5 different age categories, and you want to know if they have a different extent of worrying about global warming. You click Analyze, compare means, and then one-way ANOVA. Global warming, the variable about global warming, goes in the dependent list, and age category is the factor. Again, I included a video specifically on how to do this in SPSS as well. So this is with screenshots what it would look like. You click Analyze, you click Compare Means, and then go to One-Way ANOVA. If you click One-Way ANOVA, this window opens up. On the left side, as always, you have your menu with variables. So you find your metric scaled variable, so interval or ratio scaled variable, I am worried about global warming. And then your factor, which is in this case age categories, you click that in as well as the factor. You click OK, and this is what your output will show. The ANOVA output will show, I am worried about global warming between groups, so between your age groups, is there a significant difference? Well, the significance value is 0.000, so that means it's lower than 0.05, so yes, there is a significant difference between your age groups in how worried they are about global warming. However, which age group is actually more worried about global warming and which one is less worried about global warming? This is something we can't tell from the output as we see it right here. This is too limited. This p-value overall flags or signals that there is a significant difference between your age groups, somewhere between those different age groups, but it doesn't tell you in much detail where those differences are. So there's one more thing you need to do for that, and that is called a post hoc test. So a post hoc test, and there's many different ones. There's the Duncan's multiple range test, the Sheffy's, Stuckey's, and so on. A post hoc test allows you to look at subgroup differences really within your ANOVA. So always click that post hoc test as well. So when you are doing your one-way ANOVA in SPSS, one thing you do have to click as well is click post hoc And then this window will open up for post hoc multiple comparisons. And you select one of these post hoc tests. I highly recommend you pick Duncan because it's a very easy way to visualize which different groups are different from one another. So click Duncan, hit continue, and now your output will have an additional table, namely the post hoc table. And what it does is it lists for all the different age groups what the means are and how they are different from one another. So means that are placed in one column and separated by a line from another column means that they are different from each other. For example, 3, the average of 3 for the 18 to 24-year-olds is significantly different from 4.85, which is significantly different from each of these numbers. Now, each of these numbers, these means are placed in the same column. That means they are not significantly different from each other, but they are significantly different from each other column. Here you also see the sample sizes for each of these different age categories. So how do you report this? First, you look at the overall ANOVA p-value. If no pair is significant, if basically the flag is already not significant, then you can stop your analysis there. But if at least here, for example, your flag is significant, then you do want to continue with a post hoc test and look up and show which pairs are different from each other and which ones are not. So this is the ANOVA.